Okay, hi everyone. So for today's lesson is going to be the last lesson under the topic of algebra. So before we move on to the last part, I just want to do a very quick recap on the content that we have learned so far. Okay, so if you can recall, right? So the first lesson before your semester exam, the first thing that you learn under algebra is called as modulus function. Okay, so under the modulus, you understand what is that mean by modulus. You know some definition stuff like modulus x will be the same number if you have the x is greater or equals to 0. So the x can be negative x, or you need to change it to positive if your x is a negative number. So this is like the definition of modulus. So there are a few things that you learn under this topic. The first one is how do you actually solve a modulus equation. So under this one, you learn how to do one negative and one positive, right? And you have some formula to help you, which is if you have modulus function at both sides, then what you can try to do is you can try to square them out by using the definition of the modulus is basically equals to the square root of a square. Okay, then after that you learn things like how to solve inequality as well. So how to solve inequalities with the modulus. So you have learned like things like if you have modulus a lesser than b, meaning that you need to do negative b, a will be greater than negative b, and a will be smaller than b, right? So if you have another one, modulus a greater than b, then what you need to do is it will become a lesser than negative b, and also a greater than b. So those are the things that can help you to solve inequality. So the same thing, if you have a inequality with both side modulus, then what you can try to do, you just square it and then your sign stays the same. Okay. Then the last thing is you must need to know how do you draw a modulus graph. So in your syllabus, it mentions that you only need to know how to draw a linear graph, so meaning stuff like that. Okay. So it's like how do you draw a graph and how do you reflect it on the x-axis itself. Okay, so this is our first lesson. Then after that, we continue to something is like the division, right? The division of polynomial. So we know that normally we will use long division to do division. Yeah, so we will be writing our dividend inside, which I'll use the p here, like our original polynomial, divide by a divisor, then you will get a quotient. So if you continue to solve it and if you have something that is left over that you cannot divide already, then you will get a remainder, right? So we also know that about the degree lah. So yeah, like how do you the highest power in a polynomial is called as the degree of the polynomial, right? Then when we do division, then we can always write it in algorithm that we use it for the theorem later on. So which is the polynomial will be equals to our divisor multiply our quotient and then plus the remainder, right? Okay, so then after that from here, right, actually we can derive what we have learned recently, like the one that in fraction. So meaning if I write it in a fraction way, meaning my polynomial divide by the divisor, what do I get? I will get, sorry, my divisor d, my divisor, I will be able to get my quotient and then plus my remainder over the divisor, right? So you can imagine like the whole first equation here, when you divide everything by the divisor, you will be able to get this. So this is like very similar to the fraction, the what is that called? Normal fractions that you have. So like for example, if 7 over 4, then it will be equals to 1 plus 3 over 4. So the 1 meaning like 414, right? So your quotient is 1, then plus your remainder. When you use 7 to divide by 4, you get a remainder for 3, right? Then after that, when you will write over 4. So this is like in fraction form. Okay, so that is the second thing that we learned. Then by using this algorithm, we also have two theorems that we learn. So the first one is called as the remainder theorem. Remainder theorem. Okay, so the remainder theorem tells us that if I have a polynomial px divided by a divisor which is x minus c, then when I substitute my c in the polynomial, I'll be getting my remainder. Okay, so this only applies for like linear, because you know that when you divide by linear, then your remainder will be 1 degree lower than the divisor, right? So that's why if this is linear, then of course your remainder is a constant. Okay, then the same thing, if you have a polynomial divide by ax minus b, then your remainder will be equals to when you substitute your b over a inside your equation to get your remainder. Okay, then from remainder theorem, we got the other one which is called as factor theorem. So for factor theorem is the further derivation for the remainder theorem. So since we know that the polynomial, when we substitute c, we can get the remainder, right? So further on, if I can get the remainder equals to 0, meaning that when I substitute c inside, I get 0, what does that mean? It means that x minus c is the factor. Okay, so same thing. So meaning if here I get my remainder equals to 0, meaning that when I substitute b over a and the answer gives me 0, meaning my remainder is 0. So that's why ax minus b is my factor. Okay, so this is under the topic of the remainder theorem and the factor theorem. Okay, then the next one, you learn about things called partial fraction. So for partial fractions, you have three types. The first one is we call as a distinct linear factor. So meaning if you have something that is, I'm not going to write all, so I'm just like, if you have a linear factor that tells you ax plus b, meaning that when you try to change it, then it will be, oh, this one no need to, okay, let me try to write like this. Yeah, okay, then you have cx plus d, meaning when you try to write it in a fraction way, then it will be a constant divided by ax plus b, and plus b over cx plus d. Okay, so you just remember for every linear factor, you will have one partial fraction which you have a constant over the linear factor. Okay, so this is the type 1. Then after that, for the type 2, you learn about the repeated one. So meaning if I have over like ax plus b square. Okay, so anything that you have repeated, so it's not only for ax plus b, so meaning like if you have only the x term, you still need to do this. So as long as when you expand it, it become like repeated factor, then you need to use this formula. So when I expand this, then I get 2ax plus b, right? So it's the same thing if I have x squared. When I expand it, then I'll have x times x. So it's repeated as well. So that's why I need to do this. Okay, so it will be equals to, so the same thing, it will be a linear also, but then you will need to create two. So the first one is in one time, then after that, the second time is the square. Okay, so this is what you need to do. Then after that, the third type, you learn about the quadratic that cannot be factorized. And for this form, you only learn the form like ax squared plus b only. So you are not learning like ax squared plus bx plus c. So it's just this case that you need to learn. So what do you need to do is, since this is square, so that's why it will become ax plus b divide by ax squared plus b. Okay, so just like that. I mean, this is not a good example. I should write, okay, maybe let me write in full. Yeah, because there's no point that you want to simplify that. Ax plus b, then you have cx squared plus d. So when you want to make it into partial fractions, then you have one linear. Then after that, you have the other one, which you need to write in linear because your denominator is a quadratic, then cx squared plus d. Okay, so yeah, later on when before I start the part, right, I will be explaining the partial fractions again because I realized that yeah, there's like one or two people came to me and ask for the questions that because in your past year questions that's one question that they actually have the same degree. So that's why yeah, I think when I refer to the learning outcome, I left out the part that I mean you do not need to learn improper when you have the degree of your numerator is more than, but then maybe you need to learn for the equal. So I will be like sharing with you like the fourth type. But the idea is if you already go through the extra knowledge that I put into the partial fractions, right, you should be able to get this part already. Yeah, so I'm just doing this part so just to clarify that actually that part you might need to learn because that is not ascending. It is like the numerator and the denominator, the degree is the same. Okay. Then after that, for the last part, we learn about the binomial expansion. Okay, so for this is for your power of your expansion, which is non positive integer. Okay, so you learn that for any rational n. Okay, so meaning it can be a negative number, it can be a fraction and so on. So even a positive integer, you can use this formula, but as what I said, you have a general formula for a positive integer. There's no point that you want to use this formula which limits you to only use like 1 plus x inside the bracket. Okay, so this one will be equals to 1 plus, then we know that n x plus n times n, sorry, maybe I need to write below. Okay, then plus n times n minus 1 divided by 2 factorial and then x square plus n minus 1 n minus 2 divided by 3 factorial x cubed, and don't forget this is a infinite series. Okay, so yeah, please make sure that you don't put a last number there, and then this formula is only valid when your ratio or like your x is lesser than 1. Okay, so this is like the whole recap that we have learned so far under this topic. So today is actually not a new content for you. We are just putting so for today's learning outcome, it will be how are we going to combine these two together. So meaning like before that we are doing partial fractions individually, then binomial expansion individually. So today we are looking into the questions that you have like two, you need to do two of this in a questions itself. Okay, so the idea is that if you remember for the partial fractions I talked about that why do we need to do the simplification is that it will be helpful for us to do things like binomial expansion, integration, differentiation. So today we are going to talk about the part that how are we going to use partial fractions in binomial expansion. Okay, so let's continue with the notes. Okay, so before I move into the two example for today's focus, I just want to do the clarification for the type 4 that I mentioned just now. So I'll be showing you two methods here, but I will recommend you to do the one that I mentioned in extra knowledge. Okay, so which I will try to explain it as method 1 here. Okay, then later I'll explain in method 2, but personally for me, I don't recommend I don't recommend you to use method 2 because the idea is it is like a formula, but then you can use that because you know that your syllabus only have the situation where your numerator and your denominator has the same degree, but then it will not be applicable if you have something that your degree of the numerator is higher than the denominator. So that's why I don't want you to memorize and so on. So I recommend you to use method 1, okay, because this one can be used in any situation. So you don't have things like careless mistake if you don't realize like the degree is wrong and so on. Okay, so the first method, like what I have mentioned before, so the once you realize that if you have a polynomial, sorry, if you have algebraic fractions which the degree of the numerator and the denominator is the same, or the degree of the numerator is bigger than the denominator, meaning it is improper algebraic fractions, then do long division first, then after that you continue with your partial fractions. So yeah, personally, I think that this one will be easier, and then this can be used in any situation, no matter the degree is the same or the degree is exceeding. Okay, so like when we look at this question, right? So meaning the first thing that we need to do is just divide. So x squared minus 5 plus, sorry, minus x plus 5 divide by x squared minus x minus 2, right? Plus, sorry, plus x and then minus 2. So when you try to divide it, then you will realize that you will only have 1 here. Then after that, x squared plus x minus 2. So you will left with negative 2x and then plus 7. Okay, so with this, then you can continue. So meaning that x squared minus x plus 5 divide by x minus 1 x minus plus 2. So remember the quotient, you just write the quotient and then plus your remainder. So you're left with 7 minus 2x, right? Then divide by x minus 1 and x plus 2. So you just continue for a normal partial fractions for this part. So this is like the method 1. So method 2 is like a memorization for the formula, but please remember that you can only use it if the degree is the same. So this is not applicable if you have the degree of the numerator is exceeding the degree for your denominator. Okay, so is that anything that you have, let's say if I try to put it in a way like x square maybe, yeah, so ax square anything lah, ax square plus bx plus c, then when you divide by, let's say I have c minus e c plus f. So when you look at this, then you definitely know that they are having the same degree, right? So x squared here, then when you multiply this and you expand, then you get x squared as well. So the thing that you can do is they will have a constant outside. Then after that, you do the same thing, plus x minus e, then plus c over x plus f, like that. So meaning that you are still doing the same thing, but if they are having the same degree, then you need to plus an a in front. So when you later, when you try to expand, then, okay, so for example, if let's say I look at this question, so I have x squared minus x plus 5 divide by x minus 1 x plus 2. So what I will be getting is, you see x squared, and when I expand, I have x squared also. So the degree is the same. So that's why I have an a individually outside. Then after that, plus my b, x minus 1, and then plus my c, which is x plus 2. Okay, then after that, you can continue with your partial fraction. So x squared minus x plus 5 will be equals to a times x minus 1 x plus 2 plus b x plus 2 plus c, sorry, I write here, x minus 1. Okay, so you can continue like, okay, you see, I just try to find the a and I show you that it's actually the same. So if to find a, then we can, yeah, you only have x, right? So that's why we just do equating the coefficient for x. Okay, so you can see B, I don't have any x squared, then C, I also don't have any x squared. So meaning that my x squared is only at A. So A will be equals to 1. So you see that A and A is both equals to 1. Then after that, you can continue lah, then do your BC. So by using the idea of like substitute -2, then to get C, substitute 1 to get B like that. All right, so it depends on you like which method that you want to do, but basically they will give you the exact same answer, but the idea is just that for this method you can use in anything. So no matter your degree is exceeding or like the same, but this one, as if you use the formula of A, then you can try to imagine like actually when you do the division, if you have the same degree, then of course you have a constant only, because like same degree you cannot expect that you are going to have like multiply x or what, right? So that's why you have A individually as your quotient like that. Okay, so but just make sure that if you are using this formula, then please make sure that your degree of numerator and the denominator is the same lah. But I think you shouldn't have any problem if the question come out is like exactly follow your syllabus, because your syllabus say that there's no situation where your denominator is greater than numerator. But again, I recommend you to use this, because if you are going to learn this like further in your max or during your university, then this one will be much more helpful than memorizing this one. Okay. Okay, I'm just going to write down the answer, then after that you can try it yourself. So if you have any problem, then you can look at this is, so if you have gone through the extra knowledge, then you do not actually need to repeat this question already. It's the same example. I'm not sure it's 9 or 10, but you can check it out. Basically, it's the same question that I show here. Okay, so if you haven't tried it out, then this will be your answer. Then you can try to continue to solve it. All right. So now we'll be looking at our focus for today. When you look at today's learning outcome, you should be able to recognize that these are the learning outcomes that you actually went through before when we talk about partial fractions and when we talk about the binomial expansion. So for today's lesson, there is no new content actually, but the idea is just that I want to go through with you the questions where we try to combine both partial fractions and the binomial expansion together. So that's why when you look at the example today, it's just like two example, because I want you to spend more time in doing your past year questions and also go through your semester one exam paper as well. Okay, so for just remember today's focus, just like looking at the questions where we combine the concept of partial fractions and binomial expansion together. So now let's look at example one. Okay, let's look at number one. So given the function, express the function in partial fractions and then obtain the expansion of fx in ascending powers of x up to and including the term in x cubed, state the range of the value of x which the expansion is valid. Okay, so when you read this question, you should be able to recognize that this is a combination of a partial fractions questions and also expansion. Okay, so the first thing you need to do is express it in partial fraction first. So I hope that you still remember how to do this. Yeah, so just now we have gone through the recap as well, right? So write down your function. So same thing. So you have distinct linear factor here. So that's why a over 1 minus 2x, and then plus b, the other one 1 plus x. Okay, so make sure that it's a proper fraction. Yeah, so this is degree 1 and your denominator is degree 2. So you just straight away do whatever that you do normally. Okay, then after that, let's continue. 10x plus 1 will be identical to a times 1 plus x plus b 1 minus 2x. So since this is the part that you already know how to do, I'm not going to do it like very slowly. So yeah, so that we can try to save some time. So x equals to -1. Let's find b first. So 10 negative 1 plus 1, we substitute a, then it gives us 0. Then after that plus b, 1 minus 2 negative 1. Then I'll be getting negative 9 equals to 3b. Okay, so I'll be getting my b, which is negative 3. Then after that, I'll continue to find my a. So which I will substitute x equals to 1 over 2 so that I get 0 for the b part. So 10, 1 over 2 plus 1 equals to a, 1 plus half plus b, 0. So I have 5, 6, and then 3 over 2a. So times 12 and 4. So a equals to 4. Okay, so now you can rewrite your equation. So 10x plus, what is that, 1 divided by x, 1 minus 2x, 1 plus x will be equals to, so your a is 4, right? So 4 over 1 minus 2x plus, minus 3 over 1 plus x. Okay, so you already did the first step, which is express the fx in partial fractions. So now you need to obtain the expansion. So how are you going to do that? So when you look at this, then you need to write them into indices form first. Okay, so meaning that you need to expand one by one. So what you can try to do is, it depends on you whether you want to split this out and do individual for this, then after that you continue with 3, or you try to expand first. So meaning that I would be writing it in the form of like 4, 1 minus 2x to the power of negative 1, and then minus 3, 1 plus x to the power of negative 1. Okay, so with this, then I can decide which one to continue. So let's say I only take out this part to do. So 1 minus 2x to the power of negative 1. So your expansion, okay, remember your x must be in front. So since you have 1 plus x already, so we do not need to do any like so-called factorization in indices. Okay, so you just continue. 1 plus, so your power, 1 time your x, okay, plus power minus 1, 2 factorial, so square, plus power 3 factorial, so negative 2x power 3. So this question 1 up to term 3, so that's why that's it. So plus infinity. Okay, then after that you should be able to continue. So 1 plus 2x minus 4x squared plus 8x cubed plus infinity. Okay, so the same thing, you must write the idea of like whether this expansion valid for which term. So valid for, so your x is negative 2x, okay, lesser than 1. So meaning you have 2x lesser than 1. So x will be lesser than 1 over 2, which gives you negative 1 over 2 x up to 1 over 2. Okay, so that's your first one. So now you can continue with the second one. Yeah, so this type of question is like quite long. So the next one is 1 plus x negative 1. Okay, so the same thing, 1 plus power x 1 plus power minus 1 x square plus power minus 1 power minus 2 3 factorial, and then x3 and so on. Okay, so the same thing, just try to solve it. So you will be getting 1 minus x plus so plus x squared minus x cubed and so on. Okay, so same thing, valid for, so this one easy lah. So modulus x lesser than 1. So you have x greater than -1 and x less than 1. Okay, so now let's try to put them into an equation together. Okay, so putting back them into this form. Okay, so the same thing. So copy down whatever that you have. So I have 10x plus 1, same thing, copy the function again. Okay, so you remember just now it's 4, right? Yeah, so 4 times 1 minus 2x -1. So meaning this is the number that we want. So I'll copy down this expansion. So equals to 4 times 1 plus 2x plus 4x squared plus 8x cubed plus so on. And then the other one is like -3 for this one. So -3, 1 minus x plus x squared minus x cubed plus so on. Okay, so now you need to combine them together. Yeah, it will be quite long. So 4 plus 8x plus 16x squared plus 32x cubed minus 3 plus 3x minus 3x squared plus 3x cubed plus so on. So you need to add them together for the number that you can solve. So 1 plus 11x plus 13x squared plus 35x cubed. Okay, so this will be your answer. But the same thing, so you remember just now you have two range, right? This one and this one. So you need to combine them and find whether like what is the range that the expansion is valid. Okay, so meaning that you need a range that it can satisfy both that you want. So meaning that you have the first one is negative half x up to half. Then the second one is -1 x and 1. So you need a range that can satisfy both. It's not like this one or this one. It's like they must satisfy both so that your expansion is valid. So what you can try to do is you just draw a simple number line like what you have learned previously in P1. So like the number that you have is like -1, -1 over 2, 0, 1 over 2 and also 1. So the first range tell you that it will be in between negative half to half. Then the second one is from -1 to 1. Okay, so which is the part that satisfies both? Is going to be here only, right? Because if you take outside, then meaning it satisfies the second one but not the first one. So this is the part that we want. So valid for negative half up to up to 1 over 2. Okay, so this is how we identify. So this one is the final range that we have for this expansion. All right, yeah, so now we'll be looking at one more example together. Okay, so let's try to look at the last question before we end the lesson. So if you think that you already roughly get the idea and you want to try yourself, then after that check your answer, feel free to do so. Okay, so same thing, express the algebraic fractions in partial fractions. So 2x squared minus x plus 6 divided by x plus 1 and x squared plus 2. So by looking at this, the degree for denominator is 3 and for numerator is 2, so it's proper fraction as well, so you do not need to do long division and so on. Okay, so same thing. The first one, you have a linear factor, which is a, which will give you a partial fractions, which is a over x plus 1. Then for your second one, you can see x squared plus 2. So this is a quadratic factor that you cannot factorize. So that's why you have x squared plus 2, and then your numerator is, bx plus c. Alright, then after that, let's do the same thing that we normally do. Equals to a times x squared plus 2 plus bx plus c times x plus 1. Okay, so just a reminder, make sure that you are putting the x plus c inside a bracket, okay, so that you don't forget that your x plus 1 should multiply with bx as well. Okay, right, so same thing, do the comparison. So let's try to put x equals to -1 so that we can get a first. So 2 -1 square minus -1 plus 6 equals to a 1 square plus 2. Sorry, I should use the normal 1 square -1. Okay, -1 square plus 2, and then for this side, it will give you b square plus c times with 0, right? So yeah, I'm just going to copy down lah. Alright, so 2 plus 1, 3, then you get 9, then 1 plus, so 3a, so a will be equals to 3. So that's the first number that we get. Then after that, you can see here, so one option that you want to do is you can put square root 2 so that, no, I don't think you can do that because this part will not be negative, so a will never be a negative number because x squared will be always positive, so you can't make this part negative. So let's do the idea of like the equating the coefficient. Okay, so equating the coefficient of, since we have a already, so let's try to do the x squared first so that we can get b. So equating the coefficient of x squared. So for x squared here, I have 2, then after that equals to a, then bx. So here I have 1x squared also, so that's why a plus b. So 2 will be equals to 3 plus b, so my b will be -1. So I do the same thing, so I can get the c. So equating the coefficient of, let's see, for me to find c, right? So the easier way is using the constant. So x0, so I'll have 6 equals to 2 times a, okay, a times 2, then after that c times 1, so plus c. So since I have my a already, so let's substitute 6, 2, 3 plus c, so my c is 0. Okay, so now I can put my a, b, c inside the equation that I made just now. So 2x squared minus x plus 6 divided by x plus 1, x squared plus 2 will be equals to, my a is 3, and my b is -1, so negative x, and x squared plus 2. Okay, so now with this, then I can continue it by doing, go to the part B. Obtain the expansion that is exactly the same, then same thing in ascending power up to and including the term in x cubed. Okay, so meaning I need to expand this part. So the same thing, what I will try to do is try to write the whole thing in index first. X plus 1, x squared plus 2. Okay, so I have 3. What is x plus c here? X plus 1. Okay, x plus 1. So 3 x plus 1 -1 minus x squared plus 2 -1. Okay, So the part that you need to expand will be this and this, right? So now same thing, let's take it out. So x plus 1 negative 1. So you remember the formula, so the formula will only allows you to do 1 plus x. So that's why let's try to exchange their place. Okay, so you have this already, then now you should be able to continue. So 1 plus negative 1, 1 factorial, then times with x plus negative 1, negative 2, 2 factorial, x squared plus negative 1, negative 2, negative 3, 3 factorial x cubed, then continue. Okay, so I'll be getting 1 minus x and then plus 1, 2, yeah, so plus x squared minus minus, so minus x cubed and so on. Okay, so now next one, x squared plus 2 and negative 1. So same thing, you need to rearrange this thing. So how can you do that? So since for our a part, it should be a number, right? So that's why 2 in front. Then x squared for the b. Okay, then after that, you realize that your first term is not 1 here. So what do you need to do? You need to do the so-called factorization, right? So you take out the 2, then do the factorization. So write down your indices and make sure that you have indices for the factor that you have taken out as well. So 2, negative 1, then you have 1 over 2. So you expand normal. 1 plus next one, negative 1, 1 factorial x squared divided by 2, then plus negative 1, negative 2, 2 factorial x squared 2 power 2. Do we need to continue? Later you are going to plus them together, right? So you can see this part, yeah. So you do not have any multiply and so on. So you know that, sorry, oh, you have an x here. So maybe we need to continue, but no, you are getting x4 here already, yeah. So I'm thinking this, so because the question only went up to x cubed, right? So you know that when you try to put this expansion here, you are going to times with x. So since x squared, when I square it, I already got x4, x to the power of 4, when I multiply by x, I already get x5. So when I continue, then I will be getting x power 6. Then after that, multiply with x, I get x7, which is like much more, I mean, the part that is like unnecessary in this question because I only need up to x3, right? So that's why I only need this part. Okay, then after that, I can continue to multiply them together. So 1 over 2 plus, so sorry, should be a negative, then x squared divided by 4. I straight away multiply the 1 over 2 inside, okay? So plus also, then x 3x4 divided by 8. Okay, so this is what I have for the other. So same thing now, let's try to put them inside the equation that I have. So 2x squared minus x plus 6 divided by x plus 1, x squared plus 2 will be equal to, so 3 and my expansion 1 minus x plus x squared minus x cubed plus so on. Then my second one is minus x 1 over 2 minus x squared over 4 plus x 4 8 plus so on. Okay, so now expand it. 3 minus 3x plus 3x squared minus 3x cubed minus 1 over 2x minus, let's try to write it in this way so it's easier for us to see. So power 3 and then plus x to the power of 5. So this is 1 over 8 x power 5. Okay, then let's combine them. Sorry, infinity. So number and number, nothing. So 3 minus, so 3 and 1 over 2. So you got 7 over 2x. And then the next one, you have plus 2x squared. Since you only have 1, then x cubed you have 2 again. So minus 12. So minus 9. Is it plus? Oh, sorry, this is plus. Negative. Okay, so you get negative 3, 12, so 11 over 4 x cubed. So since the last one is x5, which is more than what we want already, so this will be your last answer. So make sure that, oh, there's one thing that I forgot again. Try to find out the valid part. Okay, so maybe we do it now. So for 1 plus x negative 1 is valid for square modulus x lesser than 1, so negative 1 up to 1. Okay, so this is for the first term. So for second one, we have the for 1 over 2 times 1 plus x square over 2 negative 1 is valid for modulus x squared divided by 2. So you will have 2 outside. Okay, so when you solve it, then you get square root 2. So x will be greater than negative square root 2 and also lesser than square root 2. Okay, so now same thing, let's try to draw the number line. So we have the, like this, and then so square root 2 and 1, which one is smaller? So square root 2 is roughly 1.414, something like that, so it should be lesser than negative 1. Okay, 0, 1, and then square root 2. So same thing, draw the first one, then draw the second one. So part that you want is over here only, so that's why your expansion will be valid for x from negative 1 to 1. Okay, so that's it for this type of question. So I think that actually the idea is pretty easy when you understand how do you do the partial fractions and the binomial expansion. It's just that maybe a lot of calculation and so on, so you might need to be like very careful on the calculation part, yeah, because it's quite long. So if you got anything wrong above, then you might got the same thing wrong as well at in below. Okay, so yeah, so hope that you can actually understand the whole thing. So try to take your time to do your exercise and so on. So that's it for today's lesson. Thank you.